So there is another big news. China, it has given the green signal to the first thorium-reacted nuclear power plant in its country. So in this session, we are going to see that what are the significant points related to this big news, what are the consequences of this incident, and how is it going to improve the chances of the China's leadership in the global energy scenario, as well as going to hamper the position of India vis-a-vis Chinese position. So hello everybody, welcome to this session. My name is Abhishek Singh and I welcome you all to the Study IQ's the big news, in which we analyze a topic daily that affects our country and our life. So let's see what is this big news and how does it impact the India's geopolitical interests. So first of all, if we talk about the big news in this session, so we will be doing another big news, that is we are actually launching a fresh batch starting from the 19th of June 2023 at 6 p.m. And this batch, the prelims to interview batch, in which we are guiding our students from the beginning of the examination, that is the prelims stage, up to the interview stage, that is the last. So guys, if you are actually planning and preparing for appearing in the examination of 2024, making it through and getting selected, so do not delay it. Join very quickly. Our batch is going to start. The seats are limited. So also at the time, you have the advantage that if you use this code ASR live, you are gonna get this course in just rupees 30,000. So that is a very important thing you must follow. Now let's come to the topic. So the topic is here basically that China, it has given the accent to establishing the first thorium-powered nuclear power plant. So basically the Chinese nuclear safety watchdog, which is the National Nuclear Safety Administration, has issued an operational permit to the China's first thorium reactor to the Shanghai Institute of Applied Physics of the Chinese Academy of Sciences. Okay, so basically the Chinese Academy of Sciences, it has got an autonomous institute called as the Shanghai Institute of Applied Physics. So it has got the permission from the Chinese Nuclear Safety Watchdog or the Nuclear Safety Authority, which is the National Nuclear Safety Administration. It has granted the permission to Shanghai Institute of Applied Physics to operate or to establish, research and operate a thorium-driven nuclear power plant. So this reactor, that will be basically working for 10 years, and in this year it is planning to start the testing operations. Okay, and if we talk about this reactor, this will be basically a 2 megawatt liquid fueled thorium molten salt reactor, which is located in the Gobi desert city of the Wuwi, right? Wuwi in the Gansu province. Okay, everyone. So basically, it is going to use the thorium, in which form the liquid fueled thorium along in the form of a molten salt. Okay. So you might have heard that the thorium that occurs not in the pure form obviously, but like any other mineral, it also occurs in the ore form, and where mostly the ore is a big chain salt compound, mostly obtained in the form of the sands or in the form of the dust. So here in China, as we can see, the location of this plant is going to be the Gobi desert city of the Wuwei, okay, Wuwei in the Gansu province. So if we observe this Chinese map, okay, if we observe this Chinese map, so we can see here it is the Gansu province. Okay, this is the Gansu province. Let me just change the color of the ink so that you can see it clearly. This is the Gansu province, as you can see. Okay, it's quite a huge province, and most of the parts of this province, that is the desert part, desert of Gobi. Gobi is a cold desert, as all of might be aware. Okay, so here this is going to be the location of this upcoming power plant, powered by thorium nuclear fuel. Now, if we talk about the further things like what is the molten salt reactor. So as we saw the term molten salt reactor, by now we must have heard the various types of the uranium powered nuclear reactors, in which the uranium is used as the fissile material, okay, as the fissile material, where uranium basically uses the heavy breeder, right, heavy water reactors, or basically the breeder, fast breeder reactors. There are different types of the uranium nuclear reactors. However, if we talk about the thorium powered molten salt reactors, so here the molten salt reactors are a type of the advanced nuclear technology that uses the liquid fuels and typically molten salts as both fuel as well as a coolant. So here the salt which contains the thorium fuel, that is basically heated up and converted to the molten state, okay, and that particular salt is used as both the fuel as well as the coolant, because as we all know, the inherent heat that is going to be generated in this particular plant is going to be lesser than the uranium powered plant. And at the same time, for the uranium power plant, due to the nature of the mineral, it was not possible to liquidify that. However, here in the form of the molten salt, it can have a dual advantage, that this same fuel which is being used in the liquid form, that can be used as a coolant also, In the uranium based power plants, we are, I think, aware that usually the heavy water or sometimes even the normal water, these are used as the coolants. There were the incidents where the molten sodium and other lighter elements, metals, they were also used as a form of the coolants. However, those experiments did not succeed much. Okay, so typically heavy water, that was the most common coolant used in the uranium driven power plants. However, here we are using the same molten salt, which is the fuel, as the coolant also. Now, these reactors are typically built in a factory and then transported to the site for the installation. So they can be installed in many types of the variable environments. In the off-grid areas, that means where there are the areas where there are no connecting grids, where we don't have the availability of the water, etc. Even in that region also, we can set up this particular type of reactor. All right. So how does it look? If we see the salt in a molten salt reactor, so molten salt reactor, how does it work? As you can see, this is basically the molten salt reactor, and it is a typical setup of a power plant, a power generation unit. As you can see here, this is basically the molten salt reactor where the molten fuel is there, and this is basically passing through a heat exchanger, right? Why does it pass through the heat exchanger? Because the excess heat is absorbed, right? Excess heat is absorbed here, and basically the part, as you can see here, the heat is coming, right? The heat is coming, and under the heat exchanger, the temperature is reduced, okay, and the spent fuel is then passed to the recycling module, okay, that is the reprocessing module, as you can see. So here the heated steam is collected, the heated superheated steam is collected and moved to the turbine and generator, that is TG set. This is called as the TG set, turbine generator set. And here the turbine is moved with the help of the steam that is obtained from the vapors of this molten fuel, and at the same time it is moving the electric generator, giving the production of electricity. Okay, so basically every power plant works in a very similar fashion. The ultimate aim is to move the turbine and thus the connected generator along with the turbine. How is turbine moved? That is the most important part. In the fossil fuel based electric power plants like coal power plant, that is thermal power plant, or the natural gas power plant. The fuel which is used to produce the steam and to move the turbine, that is basically fossil fuel. Here we are using the molten nuclear fuel, molten salt as the nuclear fuel. Which salt? Thorium salt. Okay. So I hope you got the very clear idea. All right, everyone. Now, after the spent fuel is sent to the reprocessing module, we obtain the fresh and reprocessed fuel which can be used again. So this is the biggest advantage a molten salt reactor has got over the conventional uranium powered nuclear reactors. All right. Now moving further, let us understand how is a thorium reactor different from the uranium reactor. So I have given you a few points, a few hints. However, if we talk about the uranium fueled light water reactor, and this is basically using 35 gigawatt, producing 35 gigawatt of the power, right? As you can see here, and here at the same time, this is giving much higher efficiency, the thorium fueled liquid fluoride reactor or liquid, basically molten salt reactor, that is giving the much higher using efficiency. So overall, we can say that in the terms of the power generation efficiency, thorium is reacting much better than the uranium power plant. At the same time, if we observe the particular diagram, as you can see, the uranium fueled reactor is using 250 tons of the natural uranium and basically giving us the 35 tons of the enriched uranium. What is this enriched uranium and the depleted uranium, right? So remember one thing, right? If we observe the uranium which is obtained in the natural state, that is uranium-238, that is not a fissile material. We have to get itself enriched to the uranium-235 or to the uranium-239, that becomes plutonium. Okay. So here the 235, that isotope of uranium is very less, that is just 35 ton of the enriched uranium can be obtained using 250 tons of the natural uranium and giving us a huge byproduct, a huge waste. For example, as you can see, the 35 tons of the spent nuclear waste, it needs 10,000 plus years of the storage because it remains radioactive for more than 10,000 years. Whereas the thorium fuel, just 1 ton of the natural thorium, that is convertible to the uranium-233, which is obviously radioactive, and the 1 ton of the fissile material, that is usable by 83%, right? 83%, and within 10 years, those 83% part of the fuel, they get stable. Their half-life is over. They are no more radioactive. Only 17% of the fissile product which is used, right, which is used in the fuel, only that much of the product is radioactive for the next just 300 years. So we can see from this particular diagram that a nuclear power plant which is powered by thorium produces lesser waste, and also at the same time it produces lesser radioactive materials after the fuel is spent in the power plant. So overall we can say that the waste generation, right, the waste generation in the production of the electricity from the uranium fueled light water reactor, that is very high, right, very high. As you can see, 170 metric ton of the solid waste and 1600 meter cube of the liquid waste that is generated. Whereas at the same time, for production of the 1 gigawatt year electricity from a thorium fueled liquid fluoride reactor, you can see it just generates 0.1 metric ton of the mill tailings and just 50 kg of the liquid waste, right? Thorium generates very less wastage. Okay. So overall, the safer future lies with the thorium based power reactor. However, at the same time, if we give a basic overview, like if we can just summarize the differences or the comparative points which we discussed. So fuel efficiency, the uranium reactor is doing very poor as compared to the thorium reactor. Establishment cost, uranium reactor has got comparatively lower establishment cost because the technologies which we are using, they are readily available, and in fact not that much readily available to the all countries, but definitely easily available to at least those countries which are nuclear enabled countries. Okay. But the thorium reactors, they are still in the experimental stage, and that's why they bear higher cost. The coolant which is used in the uranium plant is usually water, the different variations like D2O, that is the heavy water, or the H2O, that is the regular water. Okay. Then molten salts which are used as the fuel in the thorium reactor, they are used as the coolant as well. Sustainability, uranium reactors, they have got the lesser sustainability, and why so? Because we cannot rely on the uranium based power plants for a longer period of time. You might have heard the news also. Germany has decided to shut down all of its nuclear power plants powered by uranium. Why? Because the production which is taking place, that's very, very costly. That's very costly. Why? Not costly on the basis of the fuel charge or something. Costly because of the environmental damages that it is doing. Costly because of the, problems being faced while the burial of the waste that is produced. Right? So overall, we can say that it becomes a big challenge to do a sustainable use or make a sustainable utility of this reactor which is powered by uranium. And at the same time, the thorium reactor is having the chances of the recyclability that is absent in the uranium power plant. So waste generation, we just saw that uranium reactor produces extremely high wastes, right? And thorium reactor that produces very less waste, and also that waste is recyclable. At least 83% of the waste that is settled down in just 10 years after it is generated in case of thorium power plant, and 17% that remains up to 300 years. Whereas the uranium reactors, they produce such waste which are radioactive, lasting for more than 10,000 years. Okay, it's a huge challenge to dump that waste. Now, if we talk about the earlier attempts, so like China, which is developing this new thorium reactor, is this the first time that any country trying to develop a thorium reactor? The answer is no. Even earlier, we say there was an institute called as the Oak Ridge National Laboratory, that is ORNL, in the United States. It conducted the molten salt reactor experiment for at least 4 to 5 years in 1965 to 1969. And it was successful. It was successful in showing the feasibility of the thorium molten salt reactor. Why? Because it was in fact getting the encouragement by the US research lab, US research scientists, as well as the federal government also was supporting it. However, due to the change in the government, they actually withdrew from this project. Not just that, another early thorium molten salt reactor project, that was the aircraft reactor experiment, which aimed to develop a compact portable reactor for the potential use in the aircrafts. So the fuel problem of the aircrafts, that was to be resolved with the help of this portable molten salt reactor, which was again developed by the same ORNL, that is the Oak Ridge National Laboratory in the US. But at the same time, this project also could not be completed because of the technical and financial challenges. Okay. If we talk about the current challenges which are lying in front of the same nuclear project, which is the covering in the China. So guys, let me tell you that developing a thorium-based reactor, particularly for the use in the commercial aspect, has been a long dream for the mankind. particularly the big problems which are faced here. The first problem, the biggest problem is to reach that critical point of operation. What is that critical point of operation? It is the point where the nuclear reaction that becomes self-sustaining. For example, in the initial stage, we have to provide the ignition. We have to provide the ignition, or we call it as the initial reaction. Like in the case of the regular fuel, for example, there is a firewood. So first of all, we have to set a matchstick, right? We set a fire with the help of matchstick. Only then the fire starts burning and then the process becomes self-sustainable. Similarly, in the case of nuclear power reactors also, we have to provide the initial bombardment of the neutrons, okay, so that a chain reaction starts in the fissile material. I am taking this name fissile material repeatedly and I hope that you understand it. Fissile material is basically that radioactive substance, that radioactive nuclear fuel which can undergo nuclear fission, okay, nuclear fission. So once we are doing the bombardment of the neutrons over the fissile material, then there is a start of the chain reaction, and this start of the chain reaction leads to the splitting of the nucleus and release of the huge amount of energy. Okay, so once this huge amount of energy is generated, then this energy is further releasing the neutrons. This explosion is further releasing the neutrons, and those neutrons are bombarding even more atoms of the fissile material, and therefore a cycle starts which leads to the automatic production of the neutrons, bombardment to the atoms, dissected, and fission of the nucleus. So overall we can say that this process is a typical point, is a start at a typical point, which is the critical point. Okay. Now, controlling the operational efficiency. Now, that is also another big challenge, because we all know that the uncontrolled nuclear reactions can cause the huge devastation. They can cause the huge damages to the civilization. So it is essential to have a control over this reaction, and still we are not very much capable of doing this exercise for the thorium plants, particularly at the professional or at the commercial level. Okay, so controlling the power plant means, can we completely switch it off? Can we completely stop the reaction at any moment of time? Or can we reduce the efficiency as low as 90% of the maximum capacity? So these are the further challenges which are needed to be addressed. Then maintaining the cost efficiency, that is also a big challenge, because see, the experimental nuclear reactors based upon the thorium, they have been developed in the past as well, as we have already seen by the ORNL, basically in the US. However, making the reactors which are much more feasible for the market, for the commercial activities like the production of electricity at a larger scale for the mass uses, that is the big challenge. In fact, China has also decided to establish the research and development center very close to this 2 megawatt thorium based power reactor, because it still wants to increase the efficiency and reduce the production cost which is incurring in the establishment of this project. Okay, so currently even we observe that who is building the nuclear reactors, which country is basically building the nuclear capacity. So as you can see here, China is still leading at a very, very high position, 23,511, right? You can see megawatt electricity that is being produced. Now here, if we observe India, that is on the second, and Turkey is on the third, South Korea, UK, Russia, UAE, Japan, US, and Bangladesh. Let me tell you that do not get confused that how is Bangladesh and how are the Bangladesh and Turkey, etc. are there, because nuclear power plant for the electricity production, for that purpose the nuclear technology is available to every country if it has signed the Non-Proliferation Treaty, the NPT, the very famous one. Okay. However, If we talk about the nuclear-enabled weapons, then the nuclear weapons are available only to the limited countries, right? The members of the UN Security Council, they are officially designated. Apart from that, India, Pakistan, Israel, right? And probably North Korea and Iran are also said to have the nuclear weapons. Okay, so weapons and power production, right? Power production are two different things related to the nuclear products. Now, if we observe that basically what is the significance of this entire news and project? So thorium is basically more abundant resource. As we all know that world is facing the crunch of the energy, right? The free, you can say, crunch of the clean energy, and thorium, which is very abundant in the nature as compared to the uranium, that is going to be a very great source of the clean energy production, less riskier than the uranium-based nuclear power. And at the same time, this can also be the reason to strengthen the China's energy security and position of the country as a leader in the advanced nuclear technologies, because thorium is found in numerous countries. But the thorium-based reactor, that is operational in China only. So it is like the first come advantage. So that is basically the reason that China is probably going to be the leader in the thorium-based power production. The use of the molten salts are both as a fuel and as a coolant that allows more efficient heat transfer, and potentially it eliminates the need for large quantities of water. Till now, the use of water, the need of water was a big challenge for every type of electricity production, be it the thermal power, be it the natural gas power, be it the uranium-based power plants. However, in this type of thorium-based power reactors, the use of water in large quantities is going to be eliminated. So this is useful for even those areas which are remote, which are sparsely populated, which are having lesser water resources. That means it can be very much useful to develop the hinterlands in the various countries. At the same time, the large-scale thorium reserves. So China is having a very good amount of thorium reserve. However, there are several other countries, including India, which have bigger reserves of the thorium. For them, it can be even more significant as a scientific innovation. All right. So we can say that it's going to create a huge impact, not just for China, but for the entire world. As you can see, this particular map, this particular pie chart, it is showing the presence of the thorium fuel, and India is probably having the greatest share in the presence of the thorium fuel, right, as compared to any other country, be it Brazil, Australia, US, Egypt, Turkey, or China, which is lying here. So if we talk in a percentage wise, we can say that India commands over 13% of the currently known nuclear reserves of thorium. Brazil 10%, Australia 9%, Turkey 6%, and China has at least 2% of the globally known deposits of the thorium reserve. Okay, so we can say that this project, this project is basically going to open the path of the nuclear power plants in a new manner, because the conventional power plants based on uranium, they have also given us several scars on the humanity. For example, very recent in 2011, we saw the Fukushima nuclear power plant accident, and before that, we had the examples of the Chernobyl, etc. in the then USSR, currently in the Ukraine. So overall, we can say that despite the presence of the nuclear energy option, we were not in a very comfortable position to use. But still, India has got to see a good number of challenges, because the invention is done by China, which is obviously against the strategic as well as the other aspects of India. So India also has got the vast reserves of the monazite sands containing the thorium, and at the same time, it has also been pursuing thorium-based nuclear technologies, including the molten salt reactors. But let me tell you that Indian molten salt breeder reactor project, which started in the 1980s, okay, they have the target to develop the thorium-based breeder reactor, but still they are unable to reach to the goal. Why? Because the challenges were coming related to the materials compatibility and the fuel processing and the overall system that was very complex and financially very, very demanding. Okay. So on the other hand, another big challenge is that China is reportedly planning to sell this small thorium reactors to the other countries as the part of the Belt and Road Initiative and to enhance the Beijing's or China's global infrastructure impact. So till now, China was constructing the roads, it was constructing the industrial projects around the countries located around India. Currently, we are also going to see that it might sell the nuclear reactors too, which are, as I told you, they are very much scalable and very much portable in the size. So that is going to be a big challenge for India in the upcoming. All right, everyone. So I hope that this session might have given you a good overview related to the news coming from China, where it has granted the permission to start construction of the thorium-based power plant. So in case if you are wondering that for which part of the UPSC paper is this going to be important, so let me tell you that this is going to be important for the prelims GS portion as well as for the mains GS3, right? Mains GS3 question paper, that's again very important. So guys, if you are preparing for the UPSC examination of 2024, then this is the time to take decision and to join the Study IQ IAS for the prelims to interview program, where we are offering you the complete guidance from the very first step to the final stage of the examination at a simple cost of 29,999 rupees if you are using this code ASR Live. So the batches are going to start just on 19th of June. So be very quick and get yourself enrolled. You can get yourself enrolled not just in the English batch, but also you have the options of the Hindi as well as the bilingual batches. So do not delay it. And if you want the content of this presentation, this class, so you can definitely join my Telegram group as well by scanning this QR code. And that's all from my side. Thank you so much everyone for watching it. Take care, bye-bye, and have a great day ahead. Jai Hind.